Hello everyone, my name is Mridul Arkadi. Today I'll be covering the topic types of search trees from advanced data structures. So in yesterday's lecture we have already covered about indexing, and today we are going to cover what is multi-way search tree and what is Btree in detail. But types of search trees are many more, like B plus tree, tri tree, splay tree, red black tree, k dimensional tree, and AA tree, out of which today we are going to focus on Btree. Okay, so BST, that is binary search tree, and AVL, that is height balanced tree. We have already studied both of this, right? So even we have solved the examples of OBST. All three mentioned trees are very important considering the SPPU exams. It is having max weightage for problem solving based on BST, AVL, OBST. And today we are going to see Btree. Okay, so BST, AVL, OBST, these are binary trees with out degree 2. Okay, so what do you mean by out degree? I think you are aware of it. If this is node and this is another children connecting to the root and this is another children connected to the root, then this is a node is having out degree 2, right? This is 1 and this is 2. Okay, so BST, AVL, OBST, these are the binary trees with out degree 2. Then for the large data, these trees grow to a great height. Like when there is a great height, there is a problem, right? So to avoid this problem, we retain the properties of BST, but we increase the outgoing degree more than 2. Okay, so the multi-way, the multi-word is because of it will be the BST, but it will have out degree more than 2. So out degree more than 2 means what? Here we can have one more children or one more children. Okay, so there are many applications of this multi-way trees, like dictionary, a spell checker, or we can store the external file indices, etc. So mway trees. So we are going to see mway trees. Mway trees can have m children. It is also known as multi-way tree of order m. Okay, now let's observe the diagram on the screen. K is key, and you can observe there are more than one key in single node. Like this is 1 key, this is 2 key, and this is 3 key. So what does it mean? That more than one keys in a single node. Now don't forget the BST rule. What is our BST rule? According to which the keys which are less than K1, that should be on left side. So is it same? See, the keys which are less than K1 are on the left side, right? And so on. Now let's check the example of mway tree. Okay, so there they have drawn four-way tree. This four-way tree will be made up of m minus 1 key fields. M minus 1 key fields means 4 is our order. So 4 minus 1 will be 3. So 1, 2, 3. So your one node can have 3 key fields. Okay, and 4-way, that 4 means this can have 4 children. 1, 2, 3, 4. Getting? You'll get more clear idea when we'll check the example of Btree. So let's just go ahead and check the properties of mway tree. So these are the properties of mway tree. Each node has 0 to m subtrees. A node with k less than m subtrees contains k minus 1 keys. The key values of the first subtree are all less than the key value. the data entries are ordered, and all the subtrees will be your mway trees. Okay, so these are the properties of mway trees. You read each property and just go to previous slide and just check into this example, you'll get to know. Okay, now let's uh, focus on Btree. But basically this mway trees are appropriate for external searching. Like appropriate means it takes minimum number of disk access for searching. So mway tree is basically appropriate for external searching in minimum time. Okay, so now let's focus on Btree. Okay, this is the important concept. So Btree is having first property, that is it is a balanced multi-way tree. Okay, the second property of the Btree is it is a generalization of BST. Okay, let's just revise BST. BST's first point is it can have at most two children. What do you mean by at most two children? It can have 0 children, it can have 1 children, it can have 2 children, right? The next property of BST which we are revising is every node can have only one key. Okay, now suppose let's take example, we have the keys like 10, 20, 5 and 15. How we draw? 10 will be our root, 20 will be our 20 will be on right side as it is a BST, then 5 will be on left side and 15 will be here, right? Is it clearly visible? It is 5. Huh? Okay, I'll just write here. Oh, okay, I'll draw it again. The 10 is our root, the 5 will be on left side, the 20 will be on right side and 15 will be left of 20, right? Okay, so can you observe this is one node and this node is having only single key. This is another node, it is having only single key as 20. This is another node which is only having single key as 5. So every node is having only one key, right? So this is our second property of BST. And the third property of BST is leaf nodes can be at different levels. Okay, so which are the leaves of in this diagram? 5 and 15, right? These two are leaves and they are at different level, right? Okay, now let's go to properties of Btree now. Okay, so Btree can have more than two children. Okay, so more than two children means what? More than two children means what? A node can have number of children more than two, right? Second property of Btree is what? Can have more than one key in node, right? So if I take 10 as root, I can have 15 as root 2. Okay, we can draw such diagram like we have seen already in mway tree. Okay, so one node can have more than one key. Okay, and the third property, the leaf node should be at same level. Should be at same level. In BST, it was at different levels, right? Do you remember the concept of level? Okay, if this is a root, okay, if this is a tree, then this is one level, this is second, this is third. So these are different levels, right? Okay, let's move on. The one more property of Btree is you can observe whatever written in blue. Okay, if B tree is having m order, okay, then every node has max m children. Okay, max m children means what? If let's take example as m is 3. Okay, if m is 3, then a mway tree can have maximum 3 children. Okay, here we write key. Okay, so can you observe, if m is equal to 3, then key will be m minus 1. Can you observe this thing? Right? Okay. One more property is, for root, minimum children can be 2. Okay. And for internal nodes, minimum children can be m divided by 2. Okay, so these are the properties of B tree. Okay, we were talking about M, that is only children. Now what about keys of B tree? So let's check the property related to keys. Okay, so here is the first property in blue, that is every node has max M minus 1 keys. Correct? We have already seen it. Once again we can check. If children are 5, that is m is equal to if 5. Okay, then keys, how many keys will be there? M minus 1, that is 4 keys will be there, right? So how we can draw? Likewise, this is k1, k2, k3, k4, right? So this will be the keys, and it can have m is equal to 5, that is children's can be 5. So 1, 2, 3, 4 and 5. Getting? Okay. And the minimum, one more last B tree property is, minimum keys can have which keys? Except the root node, that can have minimum keys as m divided by 2 minus 1 keys. Okay, so these are the properties. And the last point is, any kind of insertions in the B tree, will be only in leaf nodes. Getting this point? Insertions for B tree will be accepted, but only through leaf nodes. Okay. One more last point. You can consider ceiling properties for m divided by 2 answer. So what is ceiling property? Do you remember the concept of ceil and floor function? If not, let's revise once again. Suppose m is equal to 5, then m divided by 2 means 5 divided by 2 will be 2.5, right? So if I'm saying it's 2.5, then when I'm saying answer is 2.5, sorry, if I decide answer is 2.5, okay, then if I apply ceil function to it, ceil means upward, so answer will be 3. And if I apply floor function to 2.5, then answer will be 2. Getting? Okay, so this was the part related to floor and ceil, and this all was related to B tree properties. There are many properties of B tree. You can listen to this video twice so that you will be clear about the properties of B tree. Now let's go directly to the example. See what it is written. Create B tree of order 3 by inserting values from 1 to 10. Now see, clearly input given is order 3, right? So order may be 3 or 4 or 5. In SPPU exam it can be of any order, like you have to create the B tree using order 3 or order 4 or order 5. Okay, here in this example order 3 is considered, and you have to input the values from 1 to 10. Okay, so check out step 1. What is step 1? Order given means m given, right? So m is what? 3. So what will be the maximum key? We have already seen the properties that if m is equal to 3, that means maximum children will be 3, right? So if maximum children will be 3, then maximum key will be m minus 1, that is 2, correct? So clear about step 1? Now focus on step 2. You can take pen and paper in front of you so that you can solve it with me, so that it will be more clear, right? So let's move to step 2. Okay, that values will always be in sorted order, so no need to worry about it. So when we are inserting 1 and when we are inserting 2, there is no problem. Why? Because maximum size is 2, maximum key size is 2. So we have already written 1 and 2 inserted, right? There is no point of overflow, nothing. As maximum key is 2, 1 and 2 is easily inserted. Now we are ready to insert 3. Okay, but maximum key size is 2. So what is the solution? Solution is to split, and that split will be in the middle part. So if you can observe here what I am writing, 1, 2 and 3. Okay, but 3 we cannot add because it will be overflow. So we are going to split it at the 2. Why 2? We have to split it in the middle is the rule. Okay, and whatever you will be splitting, that should go upward, like 2 and then 1 and 3. Now you will ask why 1 is on left side and why 3 is on right side. So we should not forget the rule of BST. Why? Because there is one property of Btree which we have seen in previous slides, that Btree is a generalization of BST, correct? So whenever we'll insert 3, what answer will get? 2 will move upward, 1 will go on left side and 3 will go on right side, correct? Okay, so now let's focus on step number 3. Okay, we need to insert 4 now. Okay, first of all, remember insertion only be at leaf level. You can check previous slide where we are having leaf nodes 1 and 3 present. Okay, so the 4 can be inserted either beside 1 or 3. We cannot insert 4 beside 2. Okay, why? Because there is a rule that insertion only take place at leaf nodes. Okay, so remember BST rule, compare 4 with 2. 4 is greater than 2, so come to right side. When you are coming to right side, you have one place remaining, that is vacant, which is beside 3. Okay, so 4 we are going to put there directly, right? You can observe it here, correct? So why? Because as we are having key size as 2 and we were having one vacant place, so we didn't get any problem inserting 4. Okay, now let's focus on step 4 where we are going to insert 5. Now let's start again with the first step. What is first step? We have to compare 5 with 2. When we compare 5 with 2, we are aware that we need to come to right side. When we are coming to right side, we are having 3, 4 and 5 should be here, right? But our key size is what? 2, and we are having 3, 4, 5 at same place. Whenever such situation happens, we need to split it. How we are going to split? We are going to split it in the middle part. Okay, whenever we are going to split, we are going to move it to upward position. So 4 will be upward position and then 3 will be on left side and 5 will be on right side. So how we have split? Just check here now. So 4 moved upward. It moved upward. Why? Because beside 2 there is one vacant place. So 2 and 4 in one node. and 1, 3 and 5 are inserted or placed according to BST rule. Okay. Then step 5, we are going to insert 6. We compared 6 with 2 and 4, right? So 6 is greater than 4. So we moved to right side. When we are coming to right side, we are having vacant place beside 5. So we have put 6 there. So no problem in inserting 6. Now at step 6, we are going to insert 7, right? So whenever we are going to insert 7, what we need to do is we need to split 2, 4 and 6 wala thing. Okay. So whenever we are going to split 2, 4 and 6, we need to move 4. We need to move 4 upward. So how will be the tree? Just check out here. What will be the tree? 4 will be our root, and rest all things like 2, 6, 1, 3, 5 and 7 will be placed according to BST rule. Correct? Whenever we are saying we have to insert 7, 5, 6 and 7 will be at one place. So we are having only 2 as a key. So 6 we need to move upward, right? Whenever we are moving 6 upward, in upper level we are having 2 and 4. So key is already occupied. Getting 2 and 4 is already occupied. We are having only size 2 as a key. So first of all, we got the problem in 5, 6, 7. Correct. So we moved 6 upward. But when we moved 6 upward, we got the problem 2, 4 and 6. So again we need to move 4 upward. Getting? So finally we got this tree. Now step 7. In step 7 we are going to insert 8. We don't have any problem in inserting 8 because we have vacant place beside to 7. In step 8 we are going to insert 9. When we are going to insert 9, we are having problem 7, 8, 9. So what we are going to do, we are going to put 8 upward. When we are going to put 8 upward, 6 beside place is vacant. So 8 is placed there. So no problem. And then in step 9, we are inserting 10. So whenever we are inserting 10, we are having vacant place next to, we are having next to 9. So we placed 10 there. So this is our final B tree, and this is how we have to solve the example stepwise. Okay, I hope you are clear how to solve B tree. Thank you.